Hello everyone. So here we'll see how to determine whether the discrete time signals are energy or power signal. So in earlier lectures we have seen about continuous time signal. Now let us take examples on discrete time signal. So here we are having the first example, x of n is equals to u of n. We are having this expression which we already defined, mod x of n whole square. So replacing the value of x of n here, we'll get this term as mod u of n square. Now this is u of n is nothing but our unit step function, and we know the property again, u of n is having an amplitude 1 for n greater than or equals to 0. That means for all positive values of n its amplitude is 1, and otherwise that means for all negative values of n the amplitude is 0. So based on that I can replace this value as n is equal to 0 to all positive values of n, which is upper limit as plus n. U of n will have an amplitude which is equals to 1 square. Now here it comes the summation from 0 to n, and the result of summation 0 to n will be equals to upper limit plus 1, that is going to be n plus 1. Now here I have left with one term as limit n tends to infinity. So based on that we'll get this expression as limit n tends to infinity, and the summation result is n plus 1. So when we put infinity over here, infinity plus 1 definitely infinite. So we'll get energy is going to be infinite. Now how can you get n plus 1? So let me tell you one thing. If I am counting from digit or sample 0 up to sample 10, the total number of sample from 0 to 10 are going to be 11. So if I consider instead of 10 as n, definitely it will be what? N plus 1, because 10 plus 1 is going to be 11. So here the result is n plus 1 and energy is infinite. Now if you got energy as infinite, let us come across finding the power. So here we can write power is equals to 1 upon 2n plus 1 limit n tends to infinity, and this expression as it is minus n to plus n mod u of n square. So already we have determined this value. Limit, I am putting this term as it is, 1 upon 2n plus 1 into this term is n plus 1. Now we can just simplify these terms. This is n plus 1 upon 2n plus 1. Now if you straightforward put these values as infinity plus 1, we'll get both the terms as infinity upon infinity, where we don't have any solution. So for that case, what can we do? We can take n as common from numerator and denominator. So when we take n as common from numerator, we'll get this term as 1 plus 1 upon n. Similarly from denominator, we'll get this term as 2 plus 1 upon n, and this n will get cancelled. Now we'll put those limit n tends to infinity, 1 upon infinity, anything divided by infinity is 0. Similarly here it is term 1 upon infinity is 0. So 1 plus 0 will get 1. Similarly 2 plus 0 will get 2. That means the power of this particular signal is 1 by 2, which is going to be finite. Now we'll come across the condition. Power is finite, energy is infinite. That means definitely the given discrete time signal is a power signal. Okay, so this is the solution of first function as x of n is equals to u of n. Now let us come across the second type of example, x of n as 1 upon 3 raised to n into u of n. Let us put those values again. Energy is equals to limit n tends to infinity, this summation term minus n to plus n mod x of n square, which we can replace it. We'll get this term minus n to plus n, this is mod 1 upon 3 raised to n into u of n whole square. Now here it appears u of n, that is nothing but unit step function. Obviously the limit are going to be changed from 0 to plus n. In that range it will have an amplitude 1, so we'll replace it. This is small n from 0 to plus n. We are left with 1 by 3 raised to n whole square. Now if I square this entire terms, 1 by 3, 1 square is 1, 3 square is 9, so we'll get this term as limit from 0 to plus n, and this becomes 1 by 9 raised to n. Okay, because 2 into n is 2n and 1 by 3 square will be 1 by 9 raised to n. Now in order to simplify this term, we'll use one formula that is quite generalized formula we are having. The formula is quite simple. Summation 0 to infinity a raised to n is always equals to 1 upon 1 minus a. Now here I can put the value of n as infinity, so we'll get this term as 0 to infinity 1 upon 9 raised to n. Now the simplification is 1 upon 1 minus a is nothing but 1 by 9. So if you simplify this term, this 9 minus 1 is 8 and this 9 goes ahead, we'll get energy as 9 by 8. That means energy is finite. Now if energy is finite, let us come across power. Power is equals to limit n tends to infinity 1 upon 2n plus 1 summation minus 2 plus n. This is mod x of n square. Now this entire term we have already been solved, and the result is we are having this term as 1 upon 2n plus 1, this limit which is n tends to infinity, and this value is 9 upon 8. Now this n tends to infinity, if I put it here, 2 into infinity, infinite plus 1 infinity, and 1 upon infinity is definitely 0. That means this particular term is having a value as 0. So if I multiply 0 with 9 by 8, definitely the power is going to be 0. Remember here the adjustment is quite important. Here we are having 2n plus 1 and limit is tending to infinity. So if I put it here as infinite, we'll get 1 upon infinity, which is going to be 0. That means power is 0, energy is 9 by 8. Energy finite, power 0, definitely this signal is going to be an energy signal. So this is about how to check whether the given discrete time signals are energy or power signals. One more example we can see, as x of n is equals to exponential form is there, 2 into e raised to j3 pi n. So let us write the same expression, energy as limit, this is from minus to plus n mod x of n square. Now we'll replace those values with the input signal. This is 2 e raised to j 3 pi n whole square. Now if it is there, if you square the terms, this 2 square going to be 4, and already we have seen e to the power j theta whole square is going to be 0. Mod exponential term square is always what? 1. So we are left with only one value, a limit that is tending to infinity. This entire terms as it is, 2 square is going to be 4, so I can write this as 4. Taking 4 outside, we are having limit again tends to infinity. This summation is ranging from minus n to plus n, and this is 1. 4 into 1 is 1. Now this entire summation term will have a value that is going to be 2n plus 1. Now how it is 2n plus 1? So in earlier lecture we have already discussed about how the value is going to be 2n plus 1. Quickly I will tell you, if the range is from minus n to plus n, now the entire signal is discrete in nature, that means it will start from minus n and it is ending at negative values minus 1. and then it starts from all positive values of n, that is 0 to n. So in this entire range we are having samples n plus 1, and here the samples are n. So if I add this term n plus n to n plus 1, so that summation results into 2n plus 1. If I put over here 2 into 0, sorry, 2 into infinity is infinity, plus 1 infinity, into 4 is infinity, that means we are getting energy as infinity. Now if you got energy as infinity, let us come across power. Power as limit n tends to infinity 1 upon 2n plus 1. This formula I am again keeping as it is. This is mod x of n square. Now this term we have simplified. We have that value as 4. So I can write this term as 4 into limit n tends to infinity, this summation term 1 upon 2n plus 1 into, we have that value as 2n plus 1. This simplification is having value 2n plus 1. Now this 2n plus 1, this will get cancelled. We are left with only 4. That means power of this signal is finite, which is going to be 4 watt. Now we'll come across the same condition. Energy is infinite, power is finite. Definitely the given signal is a power signal. Okay, so again we have seen 3 different types of examples. Exponential is there, 1 upon 3 raised to n u of n, and only u of n. Thank you so much.